Hi all. Okay, I don't see anyone has joined, so let's wait. Hi all. I think you can hear me, right?
Yes, yes.
Okay. So maybe we can give it a start, and then let's see if others are going to join in as well. So give me 1 minute. I think there's some problem with this. Uh, okay, fine. Fine. I think it's fine now. Okay. So until the last class, we have already seen some very basic visualizations that we have done. Let me just quickly check what was our overall plan, because I forgot the overall plan. Give me 1 minute, because then accordingly we can channel things. So as part of our curriculum, we had to cover matplotlib and cbond. We are still part of cbond, and then we were going to look into SQL and statistics. So maybe we will be looking into SQL after this, and then we can go into statistics, or maybe we can look into statistics first and then look into SQL, because it's going to be interesting uh, to look into statistics now, as we are doing a lot of data analysis kind of things. So that's what the plan is. Let's go back to our uh, notebook. Okay, so I hope you can see the notebook. So what we are going to look into, as of the last class, we looked until heat map. We are also going to look into some other examples, which I have already taken here from some links which I wanted to share with you. So I'm going to share those links with you after this call, but I just wanted to show you a few things. First of all, there is a brilliant book known as Python Data Science Handbook. This is written by a person named Jake Vanderplus. I have followed him for years when I was learning the data analysis part. I still do because he's a regular speaker in the numerous Python conferences that happens, otherwise known as PyCon. So I'm going to share this link. I'm not sure whether you have joined with phone or with laptop. Hence, what I'll do, I'll share this link in my mail when I'm going to send the files, right? So here he has a GitHub page. You can try to download this book from some sites. If I'm not able to do so, don't worry. There is a free copy of that book online as well, so that's not an issue. But it's an extract. It's not the entire book. Okay. If you want the entire book, you need to figure out a way to download a PDF, or maybe you can try to order it if orders are getting actually delivered in your respective areas as of date because of this so-called pandemic which is going on. But the main intention of this GitHub is that there's a folder called notebooks, and inside the notebooks folder you will find a lot of things which is really very, very useful. Example given, we have already covered NumPy and all these things which are actually covered in these chapters. These are divided into chapters. Okay, and then there are chapters on visualization. The only limitation I see as of now in the NumPy chapter specifically is really good. Pandas chapter is okay. So is Matplotlib, because in Matplotlib or the visualization library, it's only Matplotlib which is covered, but that's quite good actually, because only by concentrating on one, the user was able to do a lot of things. The second thing which I would like to share is this. So Seaborn is the library that we are looking at. As we know, all these libraries are actually open source, so their code is also available onto GitHub. So I just found the Seaborn source code, and I'm going to share this URL with you. And there is a folder in this URL which is known as examples, inside which there are a lot of Python files which gives you examples related to Seaborn. So this is going to be really helpful, especially when we are going to use IDEs or integrated development environments like Spider, right? So that is going to be really, really useful. The third one, or maybe a combination of 3 and 4. So this is 3, this is 4. The third one is a page which is part of the Seaborn documentation itself, where there are a lot of, you can say, tutorials explaining some of the most commonly used functions or most commonly used visualization techniques. We are going to look into a few of them right now. Okay, so these are really useful because these give you a very good start, and then you can keep this handy because whenever you're doing things related to data analysis, you may not essentially remember each and every function, right? So you can go back to these tutorials because they have worked out examples, and from there you can pick out what you're trying to do. Okay, so what we are going to look into quickly today is a very basic overview of what other plotting Seaborn can do, and then maybe we are going to move over to statistics if we have time, right? So we have already seen using Matplotlib, we were doing all the basic plots. Now the basic plots are also available here. Example given, I do have a scatter plot option as well when it comes to Seaborn. So if I say let's create a scatter plot of relationship between temperature and humidity. Just a note, all the previous cells are already executed before this class. I had executed this so that I am ready by the time and I don't have to waste any time. So I'm just going to go ahead with the code. So I'm going to say the figure size. I'm going to set the figure size to, let's say, 10,9, and then I'm going to say SNS dot scatter plot, and then I'm going to say weather dot temperature, comma, weather dot humidity. Okay, and then I'm going to say plt dot show. Hopefully I've written the function name correctly, and hence I'm actually getting a scatter plot. Let me just remove this figure sign so that I can get it in a in a simpler way. So now I can clearly see it is similar to what we did with matplotlib. If I do a plt.scatter as well, and then I take these two inputs, the output which I get over here is almost similar to what I get over here, but there are subtle differences which you see. Okay, so in case of Seaborn, you can clearly see it is clearly defining x and y axis. In case of matplotlib, as you know, we have to do that, right? So unless and until we specify, it's not going to work. But here you don't have the title. So anyways, you will have to put the title of the chart. Let's say temperature versus humidity. Okay, so this thing is not there into Seaborn as well. Seaborn does not really know what kind of title you are going to give to a chart, right? So that's what Seaborn is not going to give you out of the box, but XY axis are already mentioned, and the visualization, if you look at it, is almost similar. Now, the reason why I took this example is because it's quite clear to understand that there is not much difference between the basic plots which you have in Matplotlib. So I can say, let's compare previous output with Matplotlib and see the differences, if any. And I'm going to say plt dot show. So as you can see, there is not much of a difference, right? Only the balls or the shapes of these dots are a bigger as compared to the rest, right? So the idea of mine showing this is that basic plots are all fine. So basic plots, if you're going to do in Matplotlib, if you're going to do it in Seaborn, it's all okay. You will not find a huge level of, let's say, difference between Matplotlib and Seaborn unless and until you move on to these kind of plots. Okay, so unless and until you look into plots which are really specific to statistical analysis and that they really require some kind of visual attention, then only you are going to find the difference between using Seaborn as opposed to Matplotlib. Otherwise, both of them almost the same. Okay. The second thing I wanted to quickly show you, we have not really looked into this from a statistics kind of a perspective. Okay, but there is something I wanted to show you right away. So I would like to go back to my notebook, and I would like to see where I had the biggest positive correlation. So the biggest negative correlation was here, precipitation in with respect to visibility miles, and a good positive correlation was here. This one or maybe this one, right? So cloud cover and humidity is good. It has really good thing, and humidity with respect to dew point or dew point with respect to temperature, right? So let's say if I'm going to change this to, let's say, dew point, and let me take this and put it over here and as well as over here. Can I see any dew point is there or what? Oh, okay. Sorry, I made a mistake. So it should be something like this. P is in caps. So I have to put it here. So if I see there is quite a good relationship between the temperature and dew point. So as I see there is an increase in the temperature, there is an increase in dew point as well. There's a few outliers. You can see a few, 1, 2, or 3 outliers here. Now, the function which I wanted to show you is something like this. So if I am going to do something like this, okay, so I'm going to simply copy this and paste it over here, and I'm going to say, let's look if we are able to see the regression or progression relationship between temperature, no, sorry, this is, yes, so temperature and dew point. Okay, what I mean by wherein regression simply refers to a linear increasing or decreasing relationship amongst two or more variables. Now, if I look at more than two variables, it is very difficult for me to do plotting. Although I can try to see if there are any examples of a 3D visualization. 3D visualization is something very common when it comes to one or two of the machine learning algorithms that we're going to see. But they're not really used always. So for the data visualization purpose, we will not always need 3D plots, but there is something which is known as using the hue, and that's what we are going to look at. But for that, we need a different kind of a data set. So as of now, I just wanted to show you a linear relationship between two variables. This is really important because the linear relationships are fundamental things related to statistics, and that we're moving into statistics slowly now. This will really be important for you, and you will need to do this kind of analysis for each and every situation which you feel. Because when you go into machine learning, you will come to know that the bare minimal basic operations or algorithms which you apply when it comes to the machine learning area will almost always be dealing with the linearity of the data, the linear relationship between the features which are present in the data. So let's try to look or plot a linear relationship line, otherwise known as a regression line. Okay. I know you have not understood what is a regression line. Please don't worry right now. We are going to look into this at great depth when we look into machine learning, when we look into statistical inference. So it's going to take some time to reach that stage. At least to cover the basics of statistics is going to take some time. And then we'll reach that phase. Okay. So here the syntax is something like this. I'm going to mention the x-axis, which is my temperature. And then the y-axis is going to be my dew point with P in caps. I made that mistake last time. And then my data set is weather. So this is how you mention it. You don't mention it by dots. Okay. Then if I do a plt.show, you can clearly see what is the kind of output which you are getting here. So this hashed out line, this line which is kind of a spread, it tells you how much the data is concentrated across these areas of the line, but there is most probably a straight line which we are able to fit, and we are able to fit a linear line between these two variables, so that using this line, and then we are going to look at the mathematics when we go into statistics. Using the mathematics behind this line, we will be able to predict values. We will be able to look into the relationship of if one changes, how is the change in other, and by what means the other is going to change, or by what value the other is going to change, what quantity the other is going to change, and so on. Right. So using this kind of linear plots is really going to help you understand the progression of the data or the relationships between the variables of the data. Now, let's take one more example where we are going to look into, let's say, humidity. Okay, we have already seen earlier that humidity may not have really a linear relationship, but let's try to see if there is any linear relationship or not. So I wanted to deliberately take this example because, as you can see in the first output, we have dew point on y-axis, temperature on x. We have a straight line, and then there is a hashed out or a grayed out area. Now the grayed out area is quite compact. It is quite mean in nature. It is not flabby. It is quite small, and it is concentrated around the regression line, or it is concentrated around the straight line. Okay, later we are going to define what is a regression line and why I called that straight line as a regression line. But if you look at the second diagram, you see there is still a line. So we are able to mathematically plot a line within two variables which are not really properly linearly distributed amongst each other, as opposed to this one, right? So temperature and dew point seems to be a very good fit, but when it comes to temperature and humidity, it's quite important to see there is a spread. But irrespective of whether there is a spread, there is always a line which is passing through it, which is trying to ascertain some kind of a linear relationship between these two features. So this is a very important point to remember when you are doing a data analysis and you are trying to figure out what is, if there is a linear relationship, try to fit this line. Okay, don't always try to look into the scatter plot and try to decide whether there is a linear relationship or not. You may not be able to find the actual linear relationship unless you have very small set of, let's say, data, or you have very good graphing techniques. If I already plotted quite well, or maybe you have used other plotting softwares, let's say Tableau or something. So in that case, maybe you are going to get some help, but I would strongly recommend using this line, because when you create this line, it creates that spread around that line as well. And that spread is going to tell you a lot of things. So it's clearly telling us that in the middle values ranging 30 to 40 or maybe 30 to 42, it's a good linear relationship between temperature and humidity, except everything else. Everything else has a problem. Every other range, let's say 42 to 52, or let's say the starting range of 20 to 30, there is a problem. So there are presence of items or points inside the data which is trying to relate these two features, which are not essentially linearly related with each other, which is going to be a problem if we are trying to ascertain the value of one as opposed to the value of another. So we should not be doing that in this case. So if let's say we are going to predict the temperature tomorrow, we should not be using this variable to predict the temperature, because or we should not be using this variable only to predict the temperature. Maybe it needs a combination of other variables, because by itself it's not going to give me a good uh, linearity or a good relationship, because I can clearly see part of my data exploration itself that no, there is no such a proper linear relationship between humidity and the temperature values opposed to what I see between dew point and temperature. Okay, so that's the specific reason why I wanted to show you this graphing technique. This is not a very I mean hilariously important kind of a technique, but then it's really useful when you look at the previous graphs when we created as opposed to this graph. It is actually useful. Then there are other things which I can show. That is not this. I would like to show you one more, which is related to hue, and I'm not able to do that here because I don't have the proper, let's say, data sets. Okay, so that is the reason why I'm not able to do it right now. Maybe we are going to take a different kind of a data set, and then we are going to look into what is hue and all these things which we are going to use. Hue is specifically the color which we give when we are trying to compare two variables. Example given, maybe I can take a quick example. So let's say I have y-axis and I have x-axis. Okay, so in the x-axis I have some variable, in y-axis I have some variable, and I'm trying to plot, let's say, line charts. Okay, no, I'm trying to plot, let's say, bar charts. Okay, so these are, let's say, bar charts, and I would like to see if I can divide these bar charts using color codes when I have two kind of variables or three kind of variables in place. Example given, x gives the number of years of experience. Okay, so I'll say E, and y gives the salary. I'll say S. So it's comparison of experience by means of the salary. As I can see, the data seems to be problematic because with experience being increasing, I usually expect the salary to increase as well. So this is just a dummy example where you can see there is a dip over here. Ideally, it should be increasing like this, right? Now, if I would like to categorize or visualize this data basis the gender, okay, so what I'm going to do, I'm going to use a hue where a particular color is going to be given to male and a particular color will be given to female employees, and then that way I should be able to clearly see how much is the effective part or the relative part of each and every salary specifics or each and every salary groups or experience groups, or who are actually getting more salary basis more experience or less experience, whether they are men or whether they're women, right? So that kind of an output is really useful, and it is going to help while doing the data analysis. But for that I need that kind of a data as well. In this case I'm not able to find any such kind of categorical variable which I can make use of. So in this case, as you can see, the experience is a continuous variable, salary is a continuous variable. We are going to look into the types of variables as well, don't worry. And then we have this. Okay, so we have this gender, which is actually a categorical variable. It is not a continuous variable. So I need some kind of a categorical variable in place. Otherwise, I won't be able to do this kind of an exercise, right? So that's the point here. So there are many other functions, as I told you earlier as well. We may not be looking into each and every one of them right now, but maybe when we do the exercises, we are going to figure out how to do the visualizations. But I would strongly recommend that you don't try to remember every function. It's not going to help you. It's really not going to help you. It doesn't help me at all. When we work, we don't remember everything. We remember the basics like describe and pair plot and scatter plots and line plots and bar graphs and the histograms and so on. We may not even remember the hue, how to use that function of hue. And then we go to the documentation and we find out, because these libraries are changing very frequently. They have a certain version today. By the time in the next 6 months, maybe when you start working as a data scientist in the industry, it may well be the next 6 months in which you are going to start. In that case, that library may have changed a lot. So it's of really no point of remembering all the things. It is of really no use to remember all the technical details, because then you are going to forget the essential details. The essence is to solve a business problem, not to remember, right? So let me remove this, clear all the drawings, and then we can give it a start with statistics. In the meanwhile, if you have any questions, please let me know. I'm trying to think about something else as well. I'm going to share that with you at a later stage. I'm going to share that in our group as well. What I'm trying to think is, we are only going through the material and we are only looking at things which we are trying to learn. We are not, or at least I am not asking you to practice it at a level which you should be practicing. So maybe what I'm going to do, I'm going to figure out some questions which I can give you along with some kind of, let's say, data sets, and they can act as, let's say, practice questions for you. I'll try to give you the questions. I'll share the questions with you. I'll share the assignments, and maybe you can try to do those. Don't consider them as actual assignments which we are trying to do. This is not a class. So, but if you try to practice them, you will get a lot of idea about how to find out this kind of information from your data set, how to do proper, let's say, visualizations in a better way, and so on. Right. So, uh, is anyone having any questions, or we can go ahead?
Yes. In
Yeah.
this RH plot function, there is a light blue or grayish kind of shading around that line.
Yeah.
So,
Yes.
what is the any significance of that?
Yes. Yes.
Like
Of
this
course.
is not a linear one, and
Yeah.
how do
So
we calculate that?
yes. So how we are going to calculate that is something we will look into when we go into, let's say, machine learning itself, because I need to explain you some math first, and then only you can understand why this graph is actually mathematically different from this graph. Okay, because we don't know the mathematics right now, we can't really comment on the numbers right now. But what we can see over here, you see this gray area here. This gray area over here is quite small in the spread. You see this is quite compact here, and then the spread over here is a little bit. But if you try to compare this output as opposed to this output, you look at what is happening. There is some minimal spread here at the center, and then there is a big spread at the beginning and at the end. So this signifies that there is no proper or continuous linear relationship between your data. So here you are trying to compare, let's say, humidity with the temperature, right? In this case, as the temperature increases, I can't say that equivocally and linearly humidity is also going to increase, because the spread of my data, although it can be mathematically formulated by means of a straight line, that straight line also has a spread. It's as if that straight line contains outliers on top of them. Okay, but if you look at this, okay, here also you can see there are some outliers. It's not entirely, I mean, the ash line or the grayed outline is not entirely being put on top of the straight line. Okay, but even after that, it is quite close to it. So there is some form of strong linear relationship there, which we may want to prove. Okay, but in here, I don't think there is really anything strong, because the spread is really wide. If that spread is small, then yes, then I can be confident. Then yes, I can try to, let's say, tomorrow, if I'm going to predict the value of humidity, can I use the value of temperature as one of the factors which is going to impact the value of the humidity? Can I use that in this case? I don't think so, because if you ask me, I'm not really confident. You see the spread here and here, it is really very big. But if I look at this, I can clearly tell you, yes, if you give me a data set like this, give me a few more data. Don't give me only 1 month of a data. It's too small for me. 31 rows is not good. And we will look at why 31 rows is not good. Okay, there is a mathematics behind it. So it is not my intuition that I'm saying that 30 rows is less. 30 rows is less because of something else. So if you give me, let's say, 3 months or 6 months of data at least, or if I'm able to collect 6 months of data for New York City for the year 2016, let's say January to June, then I am quite confident only looking at the sample of data that I can predict the value of dew point looking at the temperature value. There's really a very good consolidated and concise linear relationship or growth relationship between these two variables. I hope it was clear.
Yes, and one more query.
Yeah.
I noticed one thing common between these two graphs. Like for 20 to 30,
Hmm.
the portion above the line is greater than the portion lower it, and it changes from 40 to 50 in both the graphs.
Yes.
So is it a coincidence or is it by default for all?
No, it can be a coincidence. So you are right. It is not a by default for all, because this spread of small and big, or big on and small in this case in the lower values of the temperature, and small and big in case of higher values of the temperature, is simply basis the attraction of this grayed out area towards these outlier points. You see, there are more outlier points here, right? So there are 4 outlier points at the bottom of this line when the temperature has increased. Maybe I can use a pen. So these are those 4 points which are dragging this part here. Okay, but if you look at this, how many points are really away from the straight line on the top? Here we have only 2. So that is the reason why this spread is bigger and this spread is small. The same is the case over here. Somewhere these 3 points over here, as you can see, they are quite close to the straight line. But look at a combination of these lines. This single 2 points are actually stretching this a lot. So this simply gives an indication on which direction the spread is, but it does not really tell you mathematically anything. You won't be able to prove any postulate out of here, right? Because you don't know the mathematics behind it. Even if you know the math, you won't be able to prove anything, because this line itself does not show you, or the spread itself does not show you anything concrete, right? So your intention or your intuition is correct. So if you look at the spread, you can clearly see that there is a bigger spread here as opposed to a smaller spread here, because there are lesser number of outliers dragging this spread as opposed to more number of outliers over here which is dragging this spread. Okay, so that is the same kind of a problem which we have in the next graph as well. But it does not really signify much. It's not going to help you do any analysis, if that is what your question is. It's really not going to help you understand the scenario.
Okay.
Okay. If there are no more questions, we have only 10 minutes left. So, but we will start with the statistics part, and then let's continue, and then let's see how it is going to go. So, I will try to use some kind of notes. So what I will do, I am going to unshare my screen and I am going to share something else. Okay, so I am going to share something else. Give me 1 minute. I'm going to share a notepad actually, basically, and in that notepad, I'm going to look into, or I'm going to say the notes. So let me share my notepad. Okay, I've stopped the sharing for my IPython notebook. I'm but anyways going to share that with you, right? But some of the basics are there for where we are not going to write any code. We're simply going to understand the basics and then we are going to continue. Okay. Now, we will start with absolute basics. I'm going to assume you don't know anything about statistics. Okay, so what we are going to do, and I'm going to give you some links as well. You must look into those links and you must look into those books. So let me start with the reference materials. Okay. Now, I don't know which Gita or which Bible you would really want to follow, but I can give you 2 things. and those two things should always be there with you. Actually, I'm going to give you three things. So two things. The first thing is known as Khan Academy. This person has a brilliant playlist on statistics. Okay, I have specifically mentioned playlist and not his website. Don't go to his website and look into the statistics course. It is designed for some schools. Okay, so don't look at that. Go to YouTube and find a statistics playlist which is created by Khan Academy. You should always refer to that. Don't go to his website and look into it. After you are done with this, then maybe you can go to his website, because in his website there is a problem. The problem is he has not organized it in the right way. Okay. Then the second thing is business statistics 7th edition. Okay, so this is a book. You won't be able to find the PDF as far as I have seen. You can buy the PDF or you can buy the book. There is, I understand, lockdown kind of a scenario is stopping us from buying a lot of things. Maybe once that's over, you must buy this book. Okay, and there is one more thing. Let me just quickly tell you what that was. I'm not able to remember. Give me 1 minute.
I think EBX or applied statistics.
Yes, yeah. So those are some of the other courses as well. But I would like to recommend this one. Although we are not using R here, we are actually using the Python language, right? I understand. I would strongly recommend you can find other resources to learn R, but R is not really that hard for you to learn. Yes, there are other courses available from Coursera. There is a course from Duke University. It is actually a specialization, really, really good. Then you have edX. You have other playlists on YouTube. There are really good ones. One which is from Coursera, very old course. And then there is one which I'm not able to remember right now, but its name is something like Marine Stats. Okay, so these kind of materials are there already, but I would go to them later on if I really need them. I would start with this, then I would go with this, and then I would go with this. The reason I would like to go with these two things is that these two books are beautiful and they start from exactly where they should start. They start from the very basics of the definition. That's exactly what we are going to do. So this playlist is really, really good. It gives you a very kind of baby steps to understand the statistics, assuming you don't know anything about statistics. So these are the primary things. Then it is up to you. The more you learn, the more you are going to exercise. Okay, but then it's up to you how you are going to do that. My ideology is I learn some part. I'm not going to have ever learned everything. I've learned some part, and then I started looking into things, and then I started facing problems. I went back to Google and I learned more. Okay, so that is one way. If you want to use any other way, that's also fine. Okay, but let's quickly go through some of the basics. So these are the reference things. I'm anyways going to share these notes, so don't worry. Then let's start with some of the basics. Okay, some of the basics that we're going to look into. First of all, we need to understand what are the types of data which we have available. Okay, I can overall clearly define data into two parts. One is known as quantitative data, and the other one is known as qualitative data. Okay, what do I mean by quantitative data? Quantitative data is something which I can measure in terms of numbers, right? Qualitative data can also be measured in terms of numbers, but they give you more of quality rather than the volume. Okay, we are going to look at examples and that is going to clear your doubts. Then inside quantitative, I have two kinds of variables which can exist. Okay, quantitative can either be discrete or it can be continuous, right? What is discrete, what is going to be continuous? We are going to take examples. So example given, let's say continuous. I'm going to take a small example. Yes, salary. Salary, I'm going to consider as a continuous variable, not a discrete one. Why is that not a discrete one? Is because I can say my salary is 100.21. You can say your salary is 200.221213. So there is a decimal point post which you can give any value. So infinite decimal values can be there inside that variable, inside that column. Each and every cell, each and every value in that column can have any value at all. Okay, so that's the reason why it's a continuous variable. But discrete is where it doesn't really make sense to put any decimal and try to understand what is evaluation of that. Example given, age. Okay, if you look at age of a person, 21 years old, yes, it is going to make sense. But 21 years old, 7 days, and then 31 minutes is not going to make much of a sense, because that's not going to make you a bit more older than anyone else, right? So I'm going to consider discrete variable as age, right? So age is where it is actually a numeric variable. It is actually a quantitative variable, but it's actually discrete in the value. It's going to have a certain set of values. A person can be either 0 age, he can be 100 of years of age. So I know there is a range 0 to 100 in which the value is going to fall, and there is a specific number which is going to define my age and your age and the other's age who are there in this call. So that's why it's going to be discrete. Then I have two more areas which is related to the qualitative aspect. Qualitative is a nominal variable, and other one is known as an ordinal variable. Okay, so if I look at, let's say, the nominal variable, okay, or maybe I'll take the example of ordinal. I have only less than a minute, so we are going to stop after we look at ordinal. Nominal we are going to look at in the next class. Ordinal is where using that number you can rate us, okay, or you can actually create a list or a sequence. Example given, if I conduct any exam of these classes that we are doing, and I'm going to give you grades, then I can say who is the first, who is the second, who is the third, who is the fourth. So that's really going to help understand the order. If there is an order in the data which is numeric, which has specific values, that's an ordinal variable, right? I think we don't have time as of now to go into more depth. I'll be closing the call now. Let's continue tomorrow. Okay.
Thank you.
Okay. Thanks all.